Okay, this video is about factoring special cases. And special cases, well, we're going to get into kind of what those are, but all the factoring problems we've been doing, they look like this. There's always an x squared, an x, and then usually a number. And these ABCs that I wrote in here, these all stand for different numbers. So it's not going to look like ABC when you see a problem. Like A could be 5. You'd have 5x squared plus 10x plus 4. Or 7x squared plus 3x plus negative 9. Or whatever. ABCs are just any numbers I make up basically. And all the factoring cases we've been doing usually have an A, a B, and a C. So an example, in the last video, if you watched the last one, I asked people to factor. And one of the problems I gave was 2x squared plus 6x plus 5. And if this was my problem, if I was asked to factor this, I can already tell that, okay, A is equal to 2, B is equal to 6, and C is equal to 5. That's my ABCs of this equation, which right now is not super important to us. I would know that if I want to solve this, I do that whole rectangle diamond method. I draw my rectangle, draw my diamond, like in the last couple videos, and I'd solve it, or try and solve it. But there's a lot of factor cases out there where one of these is missing, and these are called our special cases. So let's look at some examples of special cases. So I'm going to write examples of special cases, because there's a lot out there. So here's an example of some special cases. What if I asked you to factor and I gave you something like x squared minus 49? Well, totally a special case, because if I look at it, what's missing out of here is the x. In the center, if I wanted to rewrite this, it's really x squared plus 0x's minus 49. Nobody bothered writing 0x because you don't need to. It's a 0. It's kind of wasted space. But it's helpful because now I know that, okay, A, B's, and C's are visible. The B is 0. The C is negative 49. And the A, what number's in front of the x squared here? It's the one that you can't see. It's a 1x squared. So you have A equals 1, B equals 0, C equals negative 49. Totally a special case. You've got to rewrite it to look like this if you want to use your rectangle and your diamond. You got to figure out what was missing. So what if I gave you factor and I said, can you factor x squared, how about 4x squared plus 8x? Well, again, it's another special case. What's missing is the next number here. We're missing a piece. So if you had to rewrite this, you'd say, well, this is really 4x squared plus 8x plus 0. There's just a number missing here that we seem to have forgotten. So if I put the 0 in there, now it's no problem at all. We'd say A equals 4, B equals 8, and C equals 0. There's our special case. Another special case, how about this? Factor, and I give you negative 10 plus x squared plus 3x. What's special about this one is, well, it has all three parts. It has the ABCs. It's just kind of out of order. Remember, usually the x squared goes first, then the x, and then the number. So this one just needs to be kind of rearranged. If you want to make it look a little better, put the x squared first. Do the x squared, then the plus 3x, and the minus 10 goes on the end. Then it's in the order that we're kind of all used to. And so you'd say, okay, A equals the number with the x squared, so 1. B equals 3. And C equals negative 10. And it would be factorable. So there's lots of special cases out there. Mostly special cases are when something is out of order and you have to rearrange the order, or something's missing. One of the ABC components is missing and you have to turn them into zeros. And they're all factorable. So we're going to practice factoring some special cases. let's say factor this. We're going to try this one. Factor x squared minus 36. So first things first, it's a special case. It's missing an x in the middle. There's no x. So if I rewrote this, it's x squared plus 0x minus 36. So a is equal to 1, b is equal to 0, and c is equal to negative 36 when my ABCs come about. So when I go to factor, I'm going to use my rectangle diamond strategy. I'm going to draw my rectangle, make it look like this, and draw my diamond, my x, and I'm going to fill in the boxes. Usually we always put the x squared in the top corner, kind of just out of habit more than anything. The negative 36, the number always goes across from it. And then the thing in the middle, the 0x's, are what are going to be split up between these boxes. So it's kind of a weird story here. 0x goes in the bottom of my diamond. When I multiply these corners, I get negative 36x squared. So I'm looking for two numbers in my diamond. They're both going to have x's. They've got to multiply to negative 36, but add to 0. So yeah, I know there's a lot of things that multiply to 36. 1 times 36, for example, or 3 times 12 is a good one. We could do 4 times 9, 6 times 6. There's a bunch of things. I forgot about 2 times 13. There's a lot, or 18. But what I'm going to do is I'm going to look at this and say I need a negative 36. So one of these numbers has to be negative. Well, obviously, if I need 0, this is looking like my best option. A 6 and a negative 6 make negative 36 when you times them, but add together to be 0. So 6x and negative 6x go in my boxes, and order doesn't matter. You can switch yours around and be backwards from me if you want, but now you're ready to go around the outside edges. So x times x is x squared, x times 6 is 6x, and 6 times negative 6 is negative 36. And if you copy all the other edges, like you copy the negative 6 from the bottom to the top and the x from the left to the right, it matches in every corner when you times them, it works. So my factored answer is this. My two parentheses are x plus 6 and x minus 6. And I got my answer, factored. So special case. So let's try a different special case. How about this one? We'll go underneath here. Let's try factor. And we do x squared plus 6x. You might pause the video and try it on your own first if you want. But the special case situation here is there's no third number. Usually there's a plus something, a plus c. So we have plus 0 here. We have a equals 1, that's the number right here. B equals 6, and C was 0, it was missing. So we can solve this using rectangle diamond if we want. We can follow that pattern. But watch how it's going to play out. Here's my rectangle and here's my diamond. I'm going to fill the corners in. I'm going to put the 1x squared, or I'll just say x squared in this corner. The number always goes across from it, so 0 goes across from it. And we're going to split the 6x's up. So 6x goes in the bottom of my diamond here. And when you times these corners, you get 0x squared. You get 0. So I'm finding things that multiply to 0, but add to 6. Okay, there's like infinite things that multiply to 0. 1 times 0, 10 times 0, 5 times 0, 6 times 0. You could list out a giant list forever and ever. But you want to add up to 6. So obviously you need this one, because 6 plus 0 is 6. It's the best answer for us. So I'm going to use 6x and 0x, and I'm going to fill those into my boxes. And you can go vice versa if you want on this, but fill your boxes in. Go around the outside edges. X times x is x squared. Copy those x's down and across. And x times 6 is 6x. Copy the 6 across. 6 times 0 is 0, and if you copy the 0 up, 0 times x is 0x. So here's what we get for our answers. Our two parentheses, we got x plus 0 and x plus 6. So you can write it like this, x plus 0 and x plus 6, which technically is the right answer, and you can leave it and call that your answer, or you don't really need to write a plus 0. Kind of wasted space. We could just say that this is just an x and an x plus 6, and I don't need the plus 0, so you could say this is your answer right here, x times x plus 6. And there's other ways of doing these problems, but we're kind of working on the patterns right now of seeing the special case and using the rectangle diamond, even though there's lots of ways out there to do the solving, and some of them are quicker than others. So hopefully that helps.